You may have been working around this stuff for years, or maybe you're new to the job. But do you know where the hazardous chemicals are in your workplace? Do you know where the material safety data sheets are kept? Have you had hazard communication or right to know training? Your safety and the safety of your coworkers may depend on your answer to these questions. Your knowledge about hazardous materials you work with, their MSDS, and your right to know will also help you and your employer during an inspection. Welcome to Hazard Communication Training. The Hazard Communication Standard, created and enforced under the Occupational Safety and Health Administration, or OSHA, makes sure employers inform their employees about the hazardous chemicals in the workplace. This training applies whether your place of work is in an industrial plant, on a construction site, or in an office. If you've had this training before, then most likely you have some new chemicals in your work area or some new procedures to follow, so this should be familiar. If you've never had hazard communication or HazCom training before, it's information you need to know. You may also hear it called the Right to Know Standard. This is information that can protect or even save your life, the life of a coworker, or the lives of many others. At the end of this training, you should know what HazCom training is, what physical and health hazards are, how you can be exposed, and how to protect yourself from exposure. We'll also discuss exposure limits, material safety data sheets, and labels and warnings you should be familiar with. During this program, you will see the importance of scanning your work area for chemical hazards around you, focusing on the task at hand when working with hazardous materials, being mindful of each step in your task, acting safely, thinking about what you can do to eliminate or avoid exposure, and coaching others to recognize hazards and do their part towards making a safe work environment. Always remember that it only takes one worker to cause an incident. But when you work together to scan for hazards, focus on the task at hand, and act safely, everyone wins. One key reason for this training is because your employer is concerned for your safety. Another reason for this training is because it is a requirement from OSHA, the Occupational Safety and Health Administration. Every employee needs to be made aware of the potential hazards of the chemicals in the workplace. And it doesn't matter if you work directly with the chemicals or not. Your employer's role is identifying all hazardous chemicals in your workplace and informing you about them. Your employer will cover the specific chemicals that you need to know about in greater detail. But first, let's discuss what those hazards mean, like the difference between a physical hazard and a health hazard. Chemicals present two hazards: physical hazards and health hazards. Physical hazards refer to the chemical's potential for fire and/or explosion, stability in air, and its reactivity to air, water, light, sparks, or heat. For example, knowing a chemical's flash point and auto-ignition temperature are two important keys to reduce the risk of fire. The flash point is the lowest temperature at which the vapors of a chemical will ignite if there is enough of a mixture present in the air. The auto-ignition temperature is the temperature at or above which a chemical can ignite without spark or flame. These values can both be found on the Material Safety Data Sheet, or MSDS. Chemicals may be unstable or react with water. Examples include organic peroxides and oxidizers. Some may even be pyrophoric, which means they will ignite on contact with air above a certain temperature. Chemical hazards can be found in many forms at normal temperatures. They can be liquid, solid, gaseous, vapor, fume, or mist. Gaseous chemicals may be stored in cylinders under high pressure. Handle compressed gas cylinders and all other chemicals in any form by following the handling procedures listed on the MSDS. A health hazard causes a negative effect on the body due to exposure. For example, If you get a rash when exposed to a certain chemical, you are experiencing a health hazard. Health hazards are broken down into 7 categories. These are carcinogen, a chemical that causes cancer; corrosive, a chemical that causes visible destruction of skin, such as exposure to an acid; highly toxic and toxic, chemicals that cause illness or death depending on dose or concentration of contact and length of contact; irritant, a chemical that causes inflammation of the contact area; sensitizer, causes an allergic reaction after repeated exposure and may get worse with continued exposure; target organ effects, causes damage to or affects a particular organ system in the body. There are 2 other chemical-related words you need to know when it comes to health hazards. They are acute and chronic. Acute means severe or having sudden onset. Simply put, the chemical will affect you quickly. The term chronic means marked by long duration or frequent occurrence. In other words, you won't feel the effects of the chemical right away. It may be months or years before the effects are seen, or your reaction to the chemical may be caused by repeated small exposures over time. This is a big reason why hazard communication is so important. Sometimes health hazards take many years to appear. If you experience any physical symptoms that may be the result of chemical exposure, report it to your supervisor so it can be investigated. Where you work and the chemicals you work with or around play a part in how you can be exposed. There are 4 possible ways to get chemicals into your system, known as routes of entry. First and most concerning is inhalation. This is simply breathing in toxic gases, fumes, vapors, or dusts. Aerosols, smoke, and mists can also be inhaled. Once in the lungs, chemicals can be rapidly absorbed into the bloodstream or irritate the lungs. Particles from fumes can get caught in the lungs and over time cause permanent damage. The second major route of entry is absorption. While your skin acts as a nice barrier between you and a lot of bad stuff, absorption through the skin can still occur. Having open wounds, cuts, or nicks on the skin greatly increases the chances a chemical will get into your body. Ingestion is a route of entry that is not common but still possible. Most likely, ingestion of chemicals occurs when food or drink are exposed to the work environment and then consumed. That's why food and drinks are not recommended in labs or manufacturing areas. Personal hygiene is a factor too. Make it a habit to wash your hands before touching anything outside your work environment. This includes before using the restroom, eating, smoke breaks, applying cosmetics, or replacing contact lenses. The last route of entry is injection. While this is the least likely way to be exposed in most workplaces, it can happen. The use of compressed air or other gases under pressure pose an injection hazard. If you are going to be working with or around a chemical, you want to know how much exposure is too much. Exposure limits can be found on the MSDS. Here's what you're looking for. The permissible exposure limit, or PEL. This is the maximum amount of a chemical you could be exposed to over an 8-hour period without any adverse health effects. This is usually known as a TWA, or time-weighted average, and calculated from an average 8-hour workday and a 40-hour work week. Another value is the STEL, or short-term exposure limit. The STEL is the amount that a worker should not be exposed to more than 15 minutes. However, a worker under certain circumstances can be exposed to 4 STEL periods during an 8-hour workday, as long as there are 1-hour breaks in between exposures and exposure does not exceed 8 hours. One other value you will see is the ceiling value, or TLVC. This is the amount that should not be exceeded at any time. Finally, there is the IDLH value. This stands for immediately dangerous to life and health and applies to any substance that poses an immediate threat to your life, can cause health problems at very low exposures, or can interfere with your ability to escape from a dangerous atmosphere. How will you know if you're being exposed to harmful levels of a chemical? Your employer may conduct periodic testing in storage areas, work zones, and may even have you wear a portable monitor to measure your personal exposure levels. This way, your employer can determine if new controls need to be added, or if work practices are being performed properly or need to be changed. Before working with or around chemicals that are not familiar to you, check with your supervisor and review the MSDS. Make sure you understand how to handle the chemical, the hazards of the chemical, and what symptoms you may experience if you are exposed to the chemical. If you ever feel ill or anything out of the ordinary, notify your supervisor immediately. Because chemicals may pose a threat to you when you're exposed to them, you need to be protected from exposure. The primary method used to prevent exposure is through the use of engineering controls. This is when the employer tries to find a way to eliminate the hazard. An example would be substituting a less hazardous chemical or process. Ventilation is another engineering control used to reduce the levels of airborne chemicals. Another method of controlling exposure levels is through administrative controls. This usually will involve shift work or rotating workers with a minimal amount of time spent in the hazardous work area. If engineering and administrative controls have failed to reduce exposure levels, the use of personal protective equipment, or PPE, would be required. There are various types of PPE you may be required to wear and will be listed on the MSDS. PPE is designed to protect you from contact with a chemical hazard. Remember that chemicals can take many forms: solid, liquid, gas, vapor, fume, or mist. The PPE may include goggles, face shield, gloves, respirator, boots, or chemical protective clothing. Your employer will provide the necessary PPE, instruct you on how to wear and care for it, and require and enforce its use. But it is your choice to act safely and correctly use PPE. Your employer has a written hazard communication plan. Within this plan, you will be informed of the location of the MSDSs, description of the labeling system, what to do if a shipment is received without an MSDS, and the identification of all hazardous chemicals in the workplace for which an MSDS should be kept. The plan may also list the location of all hazardous chemicals. The Material Safety Data Sheet, or MSDS, is your reference for information about any particular chemical you have at your workplace. The MSDS for a chemical may be 1 page, 5 pages, or more. No matter how many pages, the MSDS contains the information that you need to know. Regulation requires the MSDSs to be produced by the manufacturer or importer, shipped with the chemical by the distributor to the customer, and kept on file by the customer or end user. The information found on the MSDS can be divided into sections, usually 16, and is usually in the standard format developed by American National Standards Institute, or ANSI. Product identification. This is the chemical name of the product, any common names, identifying numbers, and the chemical formula. Composition or information on ingredients in the container. Hazards identification gives an overview of chemical and health hazards and effects. First aid measures to take in case of exposure. Firefighting measures to use in case of fire, and information on flash point and auto ignition temperature. Accidental release measures to take if a leak should occur. Handling and storage of the chemical. Exposure control and personal protection needed to protect against exposure. Physical and chemical properties such as color and odor. Stability and reactivity are additional conditions the chemical should not be exposed to, such as exposure to air or water. Toxicological information provides dose levels that cause various health effects. Ecological information indicates how this chemical may do harm to the environment. Disposal considerations show proper handling of waste or excess materials. Transport information on how to package and label the chemical for shipment, both domestically and internationally. regulatory information on federal, state, or international regulations for this chemical, and other information that the manufacturer believes should be mentioned, such as additional labeling requirements. It's a lot of information that may seem intimidating. However, with a little training and time reviewing a few MSDSs, you can easily learn your way around an MSDS and find the information you need. All containers of hazardous chemicals are to be labeled. These labels tell you what hazards the chemical poses to you. Chemicals may be in a container, such as a 55-gallon drum, a 1-liter bottle, or in a piping system. There are a few exceptions to the labeling rule. One is when the chemical is in a portable container being transferred from a labeled container for immediate use by the employee transferring it. Another exception could be pipes, which are not considered containers. Some industrial facilities may have process containers that use other labels, placards, batch tickets, or other written forms identifying the chemical. Labels identifying hazardous materials may be in many different forms. There are DOT labels from the Department of Transportation used for shipping. There are NFPA labels from the National Fire Protection Association that warn of fire and other hazards. And there are color bar labels such as these. Here's a closer look at some of the hazard labels. DOT labels are most commonly used for shipments of chemicals. You'll see these as the large placard on the sides of tank trucks or as a smaller label on boxes. These are broken into 9 classes of hazards. Class 1, explosives. Class 2, gases. Class 3, flammable liquid. Class 4, flammable solid, spontaneously combustible or dangerous when wet. Class 5, oxidizer or organic peroxide. Class 6, a poison that is toxic, an inhalation hazard, or an infectious substance. Class 7, radioactive. Class 8, corrosive. And Class 9 is for miscellaneous hazardous material not classified by one of the other 8 classes. The NFPA and color bar labels use similar color codes and numbering scales for identifying hazards. They are the color blue for health, red for flammability, and yellow or orange for reactivity. The numbers are 0 to 4, 0 being normal or stable, and 4 being the highest hazard for that category. The white section on the NFPA label will indicate specific hazards, such as corrosive or oxidizer. The white section on the color bar label is for recommended PPE and will have a letter in the space. Each letter stands for a specific piece or group of PPE. A wallet card may be provided to help you understand the markings. One final note on labels. If you notice a label is missing, torn, or unreadable, notify your supervisor so a new label can be applied. So let's go back and see how HAZCOM training will help you. You now understand why this training is so important and required. You're ready to scan your workplace and recognize the potential chemical hazards that exist. You should also have a basic understanding of the physical and health hazards the chemicals in your workplace create. You should know how exposure to chemicals can occur and what exposure limits are. This awareness of the hazard and knowing how you can be affected should get you thinking about what can be done to eliminate or avoid exposure. Be mindful of each step in your task. In avoiding exposure, you should now understand the use of engineering controls and PPE. You should be familiar with your employer's exposure control plan. This will inform you of the actions you and your coworkers need to take to avoid chemical exposure. Understanding the material safety data sheets, warning signs, and labels will help a great deal too. All of this knowledge will help you and your employer. You will be able to answer questions that an inspector may ask. Plus, you will be able to coach others about chemical hazards and make the workplace safer. Do your part and spread the word, because everyone has the right to know.